I am telling that if VL is positive, IL will increase. It can increase from a negative value, for example, from -20 to -10, or it can increase from 10 to 20. I am telling it will increase. I am not telling it becomes positive or it becomes negative or whatever. Okay, consider this. And again the same question means if VL is negative, IL, DIL over dt will become negative and IL will decrease. And the same thing, if it is, don't say it is positive or negative, it is decrease. Okay, now we see how will be the transit. I assume that at the initial point the current is 0. From here to here, you see this voltage. You see this voltage. From 0 to pi, the voltage is positive, right? So what happens? The current of inductor will increase. From whatever it is, from which was 0, will increase. If here is pi. Why I draw like this? At the peak, VL is the largest value, right? This means that DIL over dt will be larger. DI over dt is larger means that I will increase faster. Because of this, in the middle, I will increase faster. I come to pi. Now my current is this value, whatever it is. Again, from pi to 2 pi, I see the current is, the voltage is positive, right? So what will happen? Again, then the current will increase, right? Since the voltage is positive, the current will increase. Therefore, again, I have the same thing. To this. Again, next cycle the voltage will be positive. Voltage will be positive. Always voltage is positive, right? So what happens that the current will increase till becomes infinite. Oh, what happened? Why the current became infinite? I am assuming this. Okay, I am assuming this for a purely inductive way. But if I have a resistance beside that, I have this inductor plus a small resistance. Here VO, here VL, here VR. Can you see? Yes. I see that VO is positive always, but assume VO is a constant value, and we assume VO is a constant value because it's always positive. It goes to somewhere. Assume since initially the current is near 0, and R itself is a small value. Therefore, VR is very small. VR is very small. So what happens? VO will become equal to VA, and the current will increase. After some time, at this moment, whatever, the current will become very high. Therefore, the voltage drop on this resistance, which is equal to Ri, will become high, will become large. Once it becomes large, VR becomes equal to, VO. VR becomes equal to VO. This means that I won't have any voltage drop on inductor anymore. Since the current is very large in the base diagram, the voltage drop on the resistor is very high, I won't have any current, I won't have any voltage drop on inductor. Means that LDI over dt will become 0 and the current will become constant. So, in a steady state, the current of the inductor will become a constant value. So this for highly inductive load. Again, I'm drawing the same thing for the same voltage, which is 0 to pi, 0 to pi. I am drawing this. I am drawing this current for highly inductive load for a voltage, for this voltage. You can see it is a constant value. So, whatever you should need to draw in the exam or quiz or whatever is this fixed current. You don't need to draw the transient, but I just explained you what will happen. So, this will be IO, and the amplitude will become, I put IM, whatever is the amplitude. So, for highly inductive load, the current will become a constant value. Now I want to draw the average and RMS of this value. How much will be the RMS of a constant value? It will be exactly the same thing. So if you want to, please calculate it after the class. In this way, IO RMS, if the amplitude of this current is IM, will become equal to IM. And IO RMS, IO average also will become equal to IM. Understood? Do you guys have class after this? Do you guys have class? Can I say 10 more minutes? Can I say 10 more minutes to finish this question? If someone has class, can you?
What is it essay?
Sorry?
What is it essay?
You calculate the integral. After class, you calculate the integral. Calculate the integral. It will be exactly the same. For the second part of this question, okay, I explained a lot for the first question because I needed you to learn how to calculate V average, how to calculate V RMS, how to draw the current waveform for inductive load, how to draw the current waveform for resistive load. This is required for most of your questions. For the second part, I have a thyristor instead of this diode. The difference between thyristor and diode is that in the diode is an uncontrollable device. Means that you cannot control it. Whatever the voltage it is, it will turn on or turn off. You don't have any control on turning off or turning on of it. But in thyristor, you have a control on the angle of turning on. So, because of this, I need to have two conditions for a thyristor to become on. One is it should be forward biased. Second, it should be turned on. The gate of the thyristor should be turned on. Otherwise it won't. Either it is forward bias, but it won't become on. So, that's the thing which I told you. So, if I have the same thing for the VS, the output voltage of the transformer, and I have the thyristor. I can see in the circuit that if Vs is positive, the same way which I just told for the first one, the T1 is forward bias. You can see here, I have written T1 is forward bias from 0 to pi. And T2 is reverse bias in this condition. Since T2 is reverse bias, it cannot become on. But at the same time, at omega equal to alpha, the gate of the T1 will become on. Therefore, after this moment, T1 becomes on. You see? T1 becomes on after this moment. So, what happens to the output voltage? From this point to this point, T1 is off, T2 is off. So I don't have any voltage in the output. So output voltage will become 0. But from this time to this time, T1 becomes on. Therefore, the output voltage will become exactly the same as input voltage. Exact same way as previous section. Therefore, VO will become same as Vs. The amplitude become the amplitude also is Vs. So you can see, depending on the alpha, which I choose alpha, how much should be the alpha? I can change the output voltage. It can start from here to here. But whenever the thyroid will become on, the output voltage becomes whatever the voltage is Vs. Suddenly. The same thing comes to this point. The same thing here. In this moment, again the output input voltage is negative. Input negative voltage is negative. T1 is reverse bias, the same way as diode, which are glass doors. So we cannot become on. But T2 is forward bias. You see again the same method as previous question. T2 will become forward bias. But T2 will become on at this moment, not from this moment. So from this moment to this moment, T1 and T2 both are off. Therefore, the output voltage will remain 0. At this moment, which we turn on T2, the output voltage will become minus Vs. Again, exactly the same as previous section. So, will become minus Vs. So, this will become the output voltage, therefore. Okay, now, I have this output voltage. I want to draw the output current for a purely resistive load. How will be that? Exactly the same shape as voltage, right? If you just learn like this, very simple. So this is the output voltage for the highly or purely resistive load. The current will become exactly the same shape as voltage. Here the voltage is 0, the current becomes 0. The voltage is like this, the current also becomes like this. But the amplitude will become Vm over R. And for the same question, if I have highly inductive load, with the same reasoning which I just told, for highly inductive load, the current will become a constant. The question is asking you again to draw the RMS and average of this current, which is exactly the same as it, and average and RMS of this current, which with the same method of the first section, you can calculate the average and RMS line. There will be a difference. The only difference between this question and previous question is that in the previous question, once you were calculating the integral you were calculating from 0 to pi, because in all of this part you have the signal, the sinusoidal waveform. But here, from here to alpha is 0. So you need to calculate the integral from alpha to pi for your integral. And the same way, from pi to alpha, pi plus alpha to 2 pi. Therefore, the difference is, once you calculate, IORMS will be smaller than the IORMS of previous section. And IOaverage also will become smaller than IOaverage of previous question. Okay? Sorry that I could not finish. Next week, fortunately, I myself will be here, and I will try to cover both remaining questions from this week and next week. But I hope that